Hello everyone. So welcome back to this lecture series Discrete Mathematics. So in the first lecture we have discussed about the counting principles, mainly two counting principles fundamental. One is multiplication principle, second one is addition principles, where we have to use these principles and how we can solve a real life problem with these principles we have already discussed. And also we have started discussing these two main concepts in counting. One is permutations, one is combinations. So as I have already discussed, what is permutation is the arrangement of some elements or objects where order is important. As an example, for passwords, if we change the order, then the total meaning will be changed. Second is combination. This is another kind of counting, is a selection of objects or the elements where order is not important, like choosing a menu or selecting the team members, right? I have already discussed some useful applications of this kind of concept, permutation combinations, in algorithm design, in probability decision making, and also I have discussed the beauty of this concept in cryptography, like in encryption key or codes. So now if you see the mathematical point of view, so I have already started talking about it, what is called permutation. So if you have two natural number n and r, which is obviously greater than equal 0, then p and r, or you can also denote like that, sorry. So if you also, you can denote this p and r as like that, n p r, which is nothing but n is the representing the number of elements in the set, r is the number of permutations. Okay, so r permutations of an n element set is called npr, or you can say rather p of n comma r, which is the formula is this one, n dot n minus 1 dot n minus 2 continue till n minus r plus 1. And also you can write this as a factorial n by factorial n minus r. You know what is factorial? Factorial means factorial n is formula n starting, then n minus 1, then n minus 2, continue till 3 to 1. Okay, also we discussed that if the r is 0 permutation, then the value will be 1. Simple, because if r is 0, you can see that it will be up to 1 only. Factorial n will be cancelled out, will be 1, right? Now this is the formula for permutation. Okay, now we will use some example to understand this concept, where we are using this permutation combination formula. So first we will start an example for permutation. So please remember, where we are going to use permutation, where order is important. This is the important thing. Now this is the one example. Suppose you have a lock, which is the password of this lock is 3 digits, right? And you know you have the single digits up to 0 to 9, which is 0 and 9 both are inclusive. Now question is that to open, if you set a password to open this lock, then how many different combinations of locks is possible? You have to assume that any number is not repeated. So the previous formula for permutation was for permutation with no repetition. Later we will discuss with repetition formula also. Now here no is repetition. So in that case, why you are using permutation here again? Because it is a password type of things. So here order is important. In the first round is 2, second round is also 2, third is suppose 3. So 2 to 3 can be a combination of this password, but if we change 3 to 2, same numbers, but it will not open. So that's why order is important here, right? So you have three different uh, what is called circles. If you see, here is one, this is one, this is one, this is one, three different, and the numbers are 0 to 9, right? So to solve this, first you have to think two things. If you want to use this formula, permutation of npr, which is factorial n by factorial n minus r. So basically it's very simple. We require two things. One is n, the number of elements, one is r. So here number of elements means how many numbers digits you are going to use. So you can see 0 to 9 is the total 10 digits. So the number of n value is 10, and the total permutations are r is 3. You can see because there are 3 circles. Okay, so the value of n will be 10 and the value of r will be 3, right? So now if we put in the formula, so you are getting this as I discussed. So the total number n will be 30, because in one circle the number was 0 to 10, 0 to 9, sorry, which is nothing but 10. So the second circle also 10, in the third circle also 10. So total you have number of elements 30, and the number of choice, as is a 3 circles, so number of permutations r will be 3. So 30 factorial by 30 minus 3 factorial, which is 30 factorial by 27 factorial. So you can see the 30 factorial means it will be coming 30, 29, 28, then the remaining will be nothing but 27 factorial, denoted by 27 factorial. It will be cancelled out. So the final answer will be this one, right? So you have to think about two things here. One is that uh, why permutation will be applicable in this problem. Second is uh, what is the value of n and r. And also you have to think that it is the formula of permutation with repetition or without repetition, as it is already mentioned in the questions that you have to take only without repetition elements, right? So final answer is that total 24,360, that means 24,360 different kind of combinations of the logs are possible in that case, right? So why, again I am saying why you have used permutation in this problem, because here order matters. If your password is 123 and if you want going to use the same digit but the order is 3 to 1, it will not open, right? And it is already mentioned in the question, without repetition you have to use. So we are going to use simply n factorial by factorial n minus r. Simple. Next, so suppose, so this is the one letter is given to you, flower. So how many letter you have? F L O W E R. So total 6 letter you have. Now from this 6 letter word, how many letter or how many strings of length 4 it can be formed? This is the question. So if you see individually, F L O W E R. So individually there is no repetition of F, no repetition of L, no O, no W, no E, no R. So all these letters are distinct. So there is no elements which are with repetition, right? Now question is that what is the sample space? Total number of elements you have only 6 distinct letters, F, L, O, W, E, R. So the number of n here is nothing but 6. Now how many permutations they are asking? What is the length of this permutation or sequence they are asking, which is r is 4, length 4. So ultimately 6 and 4 is the value of n and r. So why we are using permutation here? Because order. Now suppose from this, if we want to create a string, I am not saying word, because string means you can take any letters without meaning also. Word should be word. If you take word, then that should be a meaningful, but strings or sequence you can take, so you can take any letters, 4 letters. So suppose you are taking 4 letters, one is F L O W, flow. So this is one kind of string you can take of length 4. Now the same letter we are using and we are writing WOLF, for example, wolf. So you can see the same letter you are using, but the order is giving you different meaning. So that's why order is important here. Yes or no? So if order is important, then we have to use permutation. So what is the formula of permutation? and there is no repetition. So for no repetition, the NPR is formula is factorial n by n minus r again. So factorial 6 by 6 minus 4 factorial. 6 factorial means 6, 5, 4, 3, 2, 1. This is 2 factorial is 2, 1. This will be cancelled out. So 12 into 30, which is 360. So total 360 kinds different strings of length 4 you can form from this word flower using permutation. So I have given already two examples, that this is two examples. So this is one, suppose this is two. Like that you can create total 360 different strings or sequences of length 4 using the permutation without repetition formula, right? So this is another example. So we have discussed already about enough examples for the permutation problem without repetition, where we have using the permutation concept, where the order is important, right? And the formula is factorial n by factorial n minus r. N is the number of total objects or elements you have in this problem, and r is how many permutations you are doing. Now next concept is called permutations with repetition. So here the concept is that if the number of objects are n, but n1 objects of one type and n2 of second type and nk of kth type, so different types of objects are there, and the first type can be n1 objects repetition, right? So if you have this kind of objects with repetition concept, then the NPR or Pn, R, which is permutation, will be called, the formula will be, permutation formula will be this one, the total objects n factorial divided by the different types of the objects with repetition. So this is the formula. Now you are going to understand what is the formula actually with a real life example. So the similar process, if you take another letter, where we have total 7 letters, one another word, sorry, which have 7 letters. Okay, what is the letter here? Success. So you can see from this object or from this word, if you consider the number of total number of letters are 7, but if you consider the category wise, if you see the S is thrice here, U is only one time, C is twice here, E is also one time. So total 3 plus 1, 4, 6, 7, total 7. So ultimately total 7, but actually there are total 4, because few elements are repeating. So please try to understand. So we are not able to apply the first formula factorial n by n minus r factorial, because this problem with permutation with repetition. Now same, why we are using permutation I am not going to discuss again and again, because if we take uh, if you take letters from this and if we swap the letters, so the meaning or the value of the strings will be completely changed. That's why we are using permutation here. And why we are using repetition? Because the elements are repeating itself, few elements, sometimes few, sometimes all. So as I discussed, the total number of elements here 7. So that n is nothing but 7. N is nothing but 7. And if we individually take n1, n2, n3, n4, so n1 is 3, n2 is 1, n3 is 2, n4 is 4, so 1. So the formula is again factorial n total divided by n factorial n1 factorial, n2 factorial, n3 factorial, n4 factorial. So if you see, this is the calculation. So 7 factorial is the total number of elements factorial, then individual repetition elements. So this is 1 factorial, 1 factorial is nothing but 1 only. So 7 factorial, and this if you solve, you will get the value of this. If you solve, you will get 420. So total 420 distinct permutations of the word success is possible. Clear? So this is called permutation with repetition formula. So we are going to use another example again. Now suppose you have three different kind of flavors candies. One is strawberry, one is lemon, one is grape, right? And in the strawberry you have three candies. So you can see the in the strawberry case you have repetition. So not only one single individual strawberry candies you have three identically strawberry candies. So repetition. Again lemon flavor candies you have repetition 2. Grape you have 3 repetition. So the total number of candies is 8, but you have repeated elements. So again here the total number of elements n should be 8, and n1 if representing the strawberry candies flavors, then n1 is nothing but 3. If n2 is representing the lemon flavor, then it will be 2. If you have n3 is grape flavor, then you have 3. Now question is that in how many different ways you can arrange this, right? So we are going to use permutation formula, total n by n1 factorial, n2 factorial, n3 factorial. So 8 factorial divided by 3 factorial, 2 factorial, 3 factorial, right? So if you solve it, you will get the answer 560. So this is the formula for this is the problems, these are the problems for permutation with repetition. Okay, so please uh, try to understand. First one is what you have to remember where you are using permutation. So you are going to use permutation when order matters, right? And you have with repetition, first without repetition you can say, and with repetition. So without repetition the formula is that n number of total elements, then r number of permutations. So the formula is npr is factorial n by n minus r factorial, and with repetition is total number is n and individually types of n1, n2, n3 like that if continue. So the formula is now permutation is the total factorial by n1 factorial into n2 factorial into n3 factorial like this. So this is the main concept and formulas for permutation where order matters, right? Now we'll discuss combinations. So where combinations going to be used, I have already discussed where we are selecting some objects, okay, and where order is not a factor, like selecting team members and choosing menu like that. These are the examples, right? So these are the formula for combinations. So here also we have the concept called with repetition and without repetition. So without repetition we have this formula. This time combinations, this will be denoted by Cn comma r, or rather you can say NCR. So again n is the number of total elements and r is the combinations of the elements r times. So r elements combinations from the set of n elements, right? So actually the formula is we are using here in the combination, it is also involving permutation only actually. So what is the permutation formula is that PNR PR comma R divided by, so if we see PNR formula was factorial n by n minus r factorial, and if you see PRR, so the factorial r by r minus r factorial. So r minus the 0 factorial which is 1, so it will be the actually factorial n by r factorial into n minus r factorial. So using the permutation only combinations formula can be derived. Okay, so again n is the total number of elements, and from here you are going to combination, take the combinations number of combinations of r elements. Again here also if r is 0, the combinations value will be 1 for any natural number. I have already discussed n and r should be greater than equal 0, right? So this is the combination formula without repetition. Now we are going to solve some examples based on this. So please try to understand the problems first. So the question is that if you decide to have a dinner party in your home, so suppose you have many friends, but it's not always possible to invite all of them at a time. So you are just going to invite only 14 different friends of your friend circle. Okay, so you are going to invite total 14 different friends. Now you have, sorry, you have total 14 different friends, sorry, but you are not just able to invite all of them. So suppose in your class or in your college, suppose if you are working, you have only 14 friends, close friends, and out of them you want to invite only 6 because you don't have that much of enough chairs in the dining table to sit them. Okay, so now question is that out of this 14, if you inviting 6, then in how many choices you have to choose the 6 friends? I know it is your individual personal fact, but mathematically if you think the answer. So as I already discussed that why you are saying that these questions or this problem or these examples can be solved by combination, not why not in permutation, because the choice of the friends, there should not be any order. If you choose Ram first, then choose Sam first. Otherwise, you choose some Kiran first. So there will be no not a factor. There will be no issue, not an issue, right? Because choice or order of the choice is not a fact here. That's why we are going to solve this problem using combination, not in permutation. So this is the first problem, that using the seeing the problem, you have to understand which method you are going to use. So here we are using combination. Now second is we are using repetition or without repetition. Definitely without repetition, because all the 14 friends you have all are different. They are not identically same. All are different entity, different elements, right? So in that case we are going to use the combination formula, and we are going to use combination of without repetition formula. Okay, so sure, you can easily understand that here n is 14, and you have the options r of elements, combination elements is 6, right, and without repetition formula. So what is the formula here? So the formula cn comma r was n factorial by n minus r factorial. This was the formula for permutation. Just you have to add 1 factorial in the denominator. This is called combination formula. So now just substitute, n is 14, r is 6, so 14 factorial by 6 factorial into 14 minus 6. So I have the solution here. So it will be nothing but 14 factorial divided by 6 factorial into 8 factorial, because 14 minus 6 is 8. So you just do the mathematical calculation, is very easy. So the final answers you are getting 3 double not 3. So you can see that if you have 14 friends in your friend circle total, and if you are inviting the 6 friends, so the total different choices you have is 3 double not 3 different choices you have to invite them. So this is the beauty of combination. Okay, so again, in that case you are choosing 6 friends from out of different 14 friends. So why they are different? Sorry, as they are different, you are using without repetition. And here choosing the friends is not a order based, so order is not a factor here. So that's why we are going to use combination. So finally you are using combination formula without repetition, which is nothing but factorial n by n minus r factorial into r factorial. Now you just do the same simple mathematical calculation, you will get the answer. Now see this example 2. So suppose you are uh, you are taking a course which is discrete mathematics course in your university, for example. Okay, now this course will be taught by two different department faculties. One is from mathematics department, one is from computer science department. Now in the mathematics department, suppose there are 9 members, faculty members, and in the computer science department you have total 11 faculty members. Now what you have to do, you have to develop the course and only total 3 members needed for this mathematics department and 4 members needed for computations department. Now, how many choice you have to select a faculty team or a committee team? It's very easy. So here we are going to use combination, but two different thing here you have to see. So we will see different sets. This is first set, this is second set. Completely these two sets are different. Here we are using math faculties, here we are using CSE faculties. So from the maths, total fact n is 9. If you see this one, but you need the only 3 faculty from this department, so you have only 3 R. So you have to do the combination for this case differently. Don't mix with the second case. And similar way, you have different set of faculty, which is n is 11. Here you can see, and R is 4. Here it is given. So completely these two different case you have to do. Then finally you are doing the addition principle, which I have discussed in the lecture 1, because two different set you have to choose from these two faculty set. So just do the combination of two different cases, then this just add them, then you will get the answer. Simple. Okay, because why you are doing this, why you are using addition? Because I have discussed, if you are choosing, sorry, not addition, I'm sorry, if you are choosing elements from the all set, each set at least one element, then you have to use multiplication. So you have to consist a team, faculty team, where you have to use both set faculty, math also, CSC also. That means you are going to use multiplication, not addition. Please try to understand. Okay, so here we are using multiplication. If you are to choose out of this CSC and math any, you don't have to choose from each set, then you can use addition. So here you can see. So if you see the first step, first case, the combination of maths, so total 9, choose 3, so C 9 comma 3, so factorial 3 by, so first again the formula is factorial n by r factorial n minus r factorial. So 9 factorial, 3 factorial, 9 minus 3 is 6 factorial. So the final answer you can see 84. So this is the number of choice you have to choose math faculty, 3 math faculty from 9. Now similar way, you have the choice of choosing the faculty from 11 faculty members, only 4 is n, again n is 11, 4 is the r, so a factorial 11 by factorial 4 into 11 minus 4 is 7 factorial. So 7 factorial, you can see up to 7 will be cancelled, so the remaining will be here, so the value is 330. So this is set 1, this is set 2. You have to choose from these two. Like if you remember, I have solved one problem by choosing menu from the what is called restaurant. So you have to choose starter also, you have to choose main course also, you have to choose dessert also. That means from each set you have to choose at least one. Similar process, set 1 math faculty, set 2 CSC faculty, you have to choose at least one from each set. You cannot choose only math, you cannot choose only CSC. So that's why you have to use addition, multiplication principle here, not addition. If the question is asking to choose any of this, then the choice will be different. Then the choice will be 84 plus 33, sorry 330, right? So 414. You have this for this will be the answer if they are asking to choose any faculty from this set, either math or CSC. But question is asking you have to choose from each set, at least one. Okay, so you have to use multiplication formula here. So what is the multiplication of this? So first set elements total choice is 84, second total choice is 330. You just add multiply, you will get the answer 27,720. So these are the different ways to form the mathematics, as form the faculty committee or faculty team to teach the or to develop the discrete math course. So this is another example. Okay, now that was the combination without repetition. Now the formula for combinations with repetition is this one. Please remember the formula. Formula is n plus r minus 1 factorial divided by n r factorial into n minus 1 factorial. So here same kind of concept, but the elements are repeating. Okay, so if you see this example, if a bag having total 7 different denominations, okay, suppose 1 rupee one denomination, 2 rupees, 5 rupees, 10 rupees, 20 rupees, 5 rupees, like that, 7 total different, and at least 1 dozen coins in each denomination. So there's a repetition. See, 7 types, but each types having 1 dozen. So that means one is category is repeating, right? And to choose the coins, we don't have any order. You just putting your hand in the bag and you are picking up. So there is not required any order. So here you can see the answer. So the answer will be, so total 7 different denomination is there. So the n value is total 7, and total values of r is 1 dozen, which is 12. So the combination formula is, please remember, so the combination is n minus r plus 1 factorial. So n is 7. So 7 minus, sorry, n plus r minus 1. So 7 plus 12 is 19. 19 minus 1 is 18. So 18 factorial divided by r factorial, which is 12 factorial, into r, sorry, n minus 1. So 7 minus 1 factorial is 6 factorial. So 12, 18 factorial by 12 factorial 6 factorial. So answer is this one. Okay. So this is the combination with repetition formula. So again, why you are using combinations? Because you are picking up from the bag the coins, so there is no order. And why you are using repetition? Because each denomination has different coins, same kind of coins. Like 1 rupees has 1 dozen, 2 rupees also 1 dozen, 12 coins. So like that. So that's why you are using repetition. So this was the concept of permutation and combinations. Okay, so in the next lecture we will discuss another topic. Okay, so these are the some few examples you can practice. Okay, goodbye. Thank you for watching me. We'll discuss in the next lecture.